Cool. So let's get started. For those of you who looked at the pamphlet, the title of the talk was about Scala text, type-safe programmable documents. So that was out, and for those of you who looked at the website, the title of the talk became A Better Scala REPL ? And since then, it has since changed again. So currently, the title of the talk is Beyond Bash, Shell Scripting in a Typed Object-Oriented Language. So if any of you who have a laptops open want to follow along, the slides are at the URL tinyurl.com/beyondbash. So feel free to go and check it out. Get ahead of me, refer to slides I've already passed. But to begin, I'm Haoyi. I get paid money to work at the developer tools team at Dropbox. So continuous integration, Selenium, developer environments, all that stuff. I don't get paid money to work on Scala.js. And I still work on it anyway. I've been using Scala.js professionally. I've never actually used Scala professionally, so compared to many other people here, I'm technically an amateur. But today's talk is not going to be about Scala.js, nor is it going to be about developer tools at Dropbox. So today's talk, where the agenda is more or less spelled out here, is meant to answer the following question. How can we stop using the world's worst language to build our most important infrastructure? So what does this mean? If you look at a typical application, for example, you may have a client, you may have servers, multiple clients even if you're actually making money. And you may have a database that all your clients and servers talk to. For people in this room, the server may be written in Scala. For many people in this room, the clients might be some HTML, JavaScript, web scale, standards compliant thing. And the problem comes when you actually want to make changes to your system. So maybe your server is written in Scala, it's using Scala Z, very safe, reactive, back pressure, all these nice things. And that's great. But when the time comes, and maybe your database is fine, so maybe it's MongoDB, maybe it's Postgres, some are more safe than others, but everyone's safe, kind of. When the time comes that you want to work on the front-end code, suddenly it's not so safe anymore. So your JavaScript may blow up with undefined is not a function. Your CSS may have one rule that makes a whole web page disappear and become unviewable. Or your AJAX calls, which are over here, have nothing stopping them from resulting in 404s due to typos in URLs. Or at least that was the case. Now with Scala.js, the front end has no reason to be any less type safe than the back end. And even the AJAX layer between the client and server, if you're using the correct tools, you cannot have a 404 because the compiler will enforce that your AJAX requests are well formed. So Scala.js works, it's great. If you haven't checked it out, you probably should. And there's some things you learn from Scala.js. For example, casting is great. Like many people here may not like casting, but in Scala.js you do this sort of thing a lot. And realistically, in JavaScript, every single expression in your source file is effectively a cast. So having one or two casts in a large Scala.js application is like no big deal, really, compared to having every single line possibly blowing up due to a type error. Similarly, weird unsound behavior is fine as long as it's less weird and less unsound in JavaScript. And best effort error handling is great because JavaScript does not even make an effort in trying to get you good errors. So what have we learned from Scala.js? What we've learned from Scala.js is that even though it may be bad in some cases, as long as it's better than the worst thing, that's great. So you don't need to be perfect, you just need to be better than what's out there. And in this case, JavaScript is not hard to beat and being not bad. So our application looks like this. And does that mean you're done? Does that mean that we're never going to get a runtime type error ever again? Does that mean that all our code is written in beautiful, reactive, high-performance, enterprise-grade Scala? Probably not, because for many applications, underneath these beautiful architectural diagrams, you have this kind of spiky, uneven, painful underpinning of automation and deployment scripts. For example, at Dropbox, our developer tools team has a mix of Bash, Python, Puppet, Ruby, and Vagrant files to manage, often calling into each other recursively. So like Bash will call Python, call Bash, call Python, call Vagrant, call Python again. And generally, it's not that fun. So this is dangerous. And so you have a high-performance type-safe server application. You have now with Scala.js, you can have a high-performance and type-safe web front-end. But it's underpinned by this mix of stuff. There's no real description of it. But this stuff is really hard to test. And because setting up an EC2 cluster and making sure everything's configured correctly is really much harder to test than a function which takes a case class and returns another case class. It is possible to test setting up an EC2 cluster, but because it's hard to test, people tend to do it less, and therefore it ends up being more fragile. All this stuff is not type checked. So there's this huge debate about, oh, should you have types, should you have tests? Maybe we should have both because we are enterprise grade. But all the really important infrastructure has neither types nor tests in many of these cases. And that's not great. And worst of all, the consequences of this infrastructure screwing up is pretty bad. So if you have your application, everything's rosy, I make a bad application code change, I push it, web server goes down, or application server goes down, doesn't matter. I fix it, back out the chains, push again, deploy again, server comes back up. So that may be a problem, but usually it's not a terrible problem. What's worse is when the deployment and cluster goes down, and suddenly it's not so simple as fixing it and redeploying because the thing that's meant to help you deploy is all broken. And naturally, any of your clients trying to reach the front end don't work. Or if a database automation goes down, instead of taking down one database server for a kernel upgrade, you take down all your database servers and you find out that suddenly you have no more customer data. So that's not great. And it does happen in reality. So a lot of this centers around Bash. So what about Bash? Well, even though we have Python, Ruby, Vagrant, Puppet, all these other things, the core of these systems often revolves around Bash scripts calling other Bash scripts. And there are many things which are wrong with Bash. So the syntax is funky. So I don't know which of you know why this is wrong. Anyone know why this is wrong? OK, so about 10% of you know why this is wrong. So other 90% will have it blow up. Everything is global. Everything's a string. And as a result, even if statements are hard enough that 90% of this room cannot get them right. So if, for example, I want to run a script on all files with some extension, this is from Stack Overflow, one example solution, second example solution, maybe a third example solution from Stack Overflow. So this is a URL if anyone wants to grab for it. So I'm not making this up. The first one is wrong for subtle reasons that arise from treating paths and find output as a string, because I'm splitting on new lines, but file names can have new lines in some systems. So that's not right. The second one has a bunch of weird glyphs that I don't fully understand, but it's apparently a good solution. So that's the best solution we can find on Stack Overflow. And for the third one, this was not on Stack Overflow, but from my experimentation, removing these two weird glyphs seems to work. And I tried it out on Ubuntu, I tried it out on OS X, and like, okay, seems to do what I want. And it seems to work. It's often the most you're ever going to get with Bash. It's not even like it should work because that's what the documentation says, or it should work because I've used it before. But I tried it, it seems to work. I don't know. So why do people use Bash? Can we use something else as a replacement for Bash? So in order to try this, let's think of a simple use case. I want to list things in the folder I'm in. I want to look at my current Git directory. I want to make a folder, put a file inside, and delete the folder. So this is completely synthetic, but it's a kind of an indication of things that you do at the command line. So let's try it out. Over here, I have 3 shells. Top left is Bash, bottom left is Python, and on the right side is Scala. Let me just make this smaller. So I'm in a demo repo. If I want to list files in Bash, I just ls. I can git branch to check out what branch I'm in. If I want to make a folder, I can do that. File exists. OK, let's remove the folder first. And let's make the folder again. Folder's there. Echo hello, put in folder file.txt. And I can list folder, see it's there. And I can cat folder file.txt, and it worked. Let's try doing that in Python, from the Python shell, because Python is a scripting language, and I'm going to do some scripting now. So import os.list_dir dots is how you do this in Python. Why did that just turn up? I don't want that. OK, so that works. I need to call git, so I guess I need to import subprocess. And subprocess.check call paren bracket code git code close branch. So that's OK. It's not great. What else do I want to do? I wanted to make a folder with a file. So like os.makedir folder, I guess already exists. So let's say I rm-rf the folder here, and let's say I make it here, so now it works. I can list it again, you can see the folder now exists. And what else what was I meant to do? I was meant to make a file. So I open folder /file.txt dot, I think I need to say it's in write mode, dot write hello. And if I read it, you can see the data's there. And if I remove it, it blows up. So I actually need import shutil, shutil.rm3 folder. And now if I list there, it's gone. So that was kind of funky. So let's try doing this in Scala. So import java io file, new file dot list. Nope, wrong. So okay, the folder's gone. I need to what was I meant to do? I was meant to list, well, I probably listed. So import sys.process and then seek git branch dot bang. So this is not that much worse in Python. New file folder dot make dir. So that seems to have worked. And then I need to write to a file. How do you write to a file in Scala? How to write to a file in Scala. So I am doing this, but I would bet money that most of you would do the same thing. So this is how you write to a file in Scala. It's one of the many ways. So let's stick that in. Folder file.txt get bytes. Okay, so new file folder dot list. Okay, it seems to have worked. How do I delete a folder in Scala? So a new file folder dot delete. And then list, and it's still there. It's okay, so how do I delete a folder in Scala? I misspelled in. Google should know. No, Google thinks it's IntelliJ, IN. So I need to delete the directory recursively. I could use Scala IO, but apparently that's dead for the last 4 years, so let's not use that. Here's something that's not dead. It's simple delete file, and I want to delete that. And if I new file dot list, it's gone. Okay, so that probably answers the question of why do people use bash? Can we use something else? And the answer to that question is probably no, you cannot use something else. So even like bash is okay, Python is somewhat clunkier. Doing it in Scala is a huge pain. So why is that? Bash is better because you take 24 characters rather than 280 characters to delete a folder. Even in Python, you're looking at a 2x or a 6x increase in verbosity. And that's too much because when you're typing things, I really only care about these important bits and the rest is just trash. And when you're doing it interactively, how much you type really does matter. Go away, you manage software updates. Okay. So bash is better because there's less syntactic ceremony. Bash is better because the common operations are short. I just type ls instead of new file dot list. Bash is better because of fewer keystrokes. Bash is better because the commands do what I want. And removing a folder with the correct flags kills the folder regardless, which is usually what I want. I almost never want it to kill the folder. Oops, but if there's something inside, I shall not kill it and not tell you. And I think the last two are pretty important. So the Ammonite-Ops is a library that is meant to provide these things, these features in Scala. The interesting thing is that none of these features are theoretically interesting. None of them should require a PhD thesis to implement. I can make my commands take fewer characters, and I can make them do what I want. So I tried to do that. So Ammonite-Ops, the goals are basically have a library which does more or less what I want. At the goal, let's say no more than 2x as verbose as bash. So Python is 2 to 6x, Java is maybe 10x, Scala is same as Java. Let's aim at 2x. And let's say that it should be safer than working with Python or Java.io or NIO, because if it's more dangerous and it's as dangerous as bash, what's the point of this? As non-goals, I'm not aiming for monadic pure dependency type safety here. So if you guys have a problem that you're writing too much Haskell, that's great. This is not the library for you. This is meant to replace bash. And similarly, it's not looking for a reactive manifesto accreditation. Everything is synchronous, everything is blocking, everything is heavyweight. And it's not aiming for a 50-year enterprise maintainability. So Ammonite-Ops lets you write code like this. So instead of git status, I have percentage as a way of shelling out, so percentage git, and I have to quote the status because it's literal. So here I use a symbol to save one character. Instead of rm folder file, myfile.jpg, I rm bang folder myfile.jpg with some quotes. Slightly more verbose, but overall not overwhelmingly so. And I can show it to you in action. So if I import Ammonite.Ops, import implicit working directory, so it knows what directory I'm in. I can shell out to git, I can do git status, git's kind of dirty, git branch, ls, make their like cwd/folder, ls. So it's kind of hard to read, but somewhere in here you'll see demo/folder has been created. And I can rm cw/folder, and it's gone. So that's a taste of what Ammonite-Ops gives you. It gives you short commands that mirror what bash does after a single import. These commands do what you want. There's no futzing about is it removing a folder, is it removing a file, is it removing a folder children. It removes it. Like what you told it to remove it removes whatever it can find there, or at least it tries to. And there's no ambiguity in passing the arguments. For example, whether or not CWD has a space, the current working directory has a space in it, should not randomly cause it to think it's two sets of arguments instead of one. And because all of this is in normal Scala, it gets passed and interpreted correctly regardless of how the arguments look. So one interesting thing about Ammonite-Ops is that all your commands return structured data. So for example, ls of your current working directory returns a sequence of paths, which you can iterate over using for each. And the paths themselves are structured data, so you can use, they actually have attributes, like the extension is an attribute. You don't need to munch with regexes and other things. You just say path of x, check if it's temp, and do things to it. So bash supports piping. And if you've already, there's no reason why Ammonite-Ops should not support piping as well if the goal is to make something that's similar to bash so that we have some hope of replacing it. So Ammonite-Ops provides a bunch of basically aliases for methods on common types. For example, there are a bunch of traversable aliases that look like pipes and basically do traversable things. You have this forward pipe, they often call it, on any, which basically reverses it to call the function. And you have bang, which just calls the function and saves you parens and does nothing else. So this will not pass your 50-year enterprise accreditation test. But it does pass the make things short so that people don't mind typing it at the REPL test. And that's the only purpose that these things solve. So putting it together, Ammonite-Ops gives you concise file system operations. So listing is literally 6 characters or 7 characters of a space rather than a whole bunch. You get structured and concise path operations, which I didn't really go into detail, but you combine paths using slash and symbols and strings for the path segments rather than trying to splice strings together using plus. So you don't need to worry about, oh, when I combine it, do I need to add a slash in between the two paths or not? You just use slash and it combines in the correct way. And it gives you pipes as aliases for collection methods. And that's where things get interesting. For example, if I want to find the total size in bytes, in characters of all the Scala files, I think this is in bytes. The total size in bytes of all the Scala files, I simply list everything, this is an alias of filter. So filter the ones where the extension is Scala, map them to their size, and sum it. And we can see it in action here. So I am in this folder. Let's look at a more interesting folder. So let's do a recursive listing of the current working directory. So that gives a bunch more stuff. Filter x equals Scala pipe dot size some. So this is something that would take minutes to write if you are doing it using normal Scala file system APIs. And maybe that's fine if you're committing code to some long-term project. But if I just want to get this answer and get on with my life, minutes is unacceptable, especially when the alternative is I can do it in 5 seconds or 10 seconds. So further examples. I want the recursive line count of every JavaScript file within this folder. In Bash, it looks like this. With Ammonite, it looks like this. One line, about half again as many characters. I'm not going to try to pretend to tell you that this is so much strictly better than this, but it's not that much worse. And it's actually something that you can acceptably type at the command line, like I just did over here, right in front of you, without looking up any documentation. So other examples, I want only the .files in the current folder. In Bash, it's like that. In Ammonite-Ops, looks like that. And we can try it. So if I list, for example, my home folder, there are a bunch of files there. I want to filter the files whose last path segment, first character, equals dot. And I can print line because the REPL sucks at echoing things. And here you have it. This is this kind of interactive experience that Ammonite provides, that Bash provides, that is traditionally been lacking in many of these non-Bash languages, and is why people keep using Bash, even though people acknowledge it is not that great a language. So, about again half as many as characters, half again as many characters, which maybe is acceptable. Last example, I want the top 7 files in the current working directory. So find ls -sort -nrk7 pipe into head 7. The Ammonite version lists recursive the current working directory, map to a tuple of the size and the original file path, sort by the negative of first element in tuples of size, take 7. So again, about half again is verbose, so that's not great, but arguably easier to read. So who here knows what -nrk7 does? 2 people, great. 3 people, 4 people. Okay, so who here knows what sort by does and take? So you're paying about 50% verbosity in exchange for a 75x increase in people who can understand your code, which arguably is an acceptable trade-off. What? I could have done sort by dot size. That's very clever. I did not think about that. So this does work. So what does Ammonite-Ops gives you? It gives you easy, convenient file system ops in Scala that are almost as concise as Bash. Not quite. In Bash, this is ls with nothing else, but 2x. The goal was 2x, not 1x. But it's definitely less for typing in Java.io, even Java.nio, or even doing this in Python. It's much less typing. And even though it's less typing, the data model is much better. So in Ammonite-Ops, paths are not strings. Like multiple strings can convert to the same path. Appending strings as paths usually gives you invalid paths in different ways. And with Ammonite-Ops, you do not need to think about this at all. And in fact, many invalid combinations of paths, for example, concatenating 2 absolute paths together is statically prohibited by the compiler. Furthermore, results from commands aren't strings either. I get a sequence of paths. I don't get some byte stream. I don't need to split on new lines and worry about file names which contain new lines. I just take the structured data and can map that map filter, do whatever I want with it. So this begs the question, can we use Ammonite-Ops plus the Scala REPL as a default shell? So let's try doing some real work with this. Well, some fake real work. So I already have Ammonite-Ops listed here. I can say git diff. So there's a bunch of stuff. I can git commit -am, well, -a, let's say, and then you do this manually. Oops, I need to say blah. So sub-processing out to open Vim and other things from your REPL is very convenient. As you can see, I can open Git, I can open Vim. So git status, let's say I want to git push. So it kind of works. It's not great because, like, for example, this is bloody hard to read. If any of you are trying to read this, it's not great. And if I make a mistake, for example, I try to open up SBT, like, why wouldn't you open up SBT? And you open up SBT and you decide, like, well, after doing, what do you do with SBT? Maybe you're doing a compile. And I get bored and I go kill it. And I get kicked out of my Scala shell. And that's rather unfortunate. So in general, it's not really good enough. Like, it's kind of close, but it's not there. You can't really use it without constantly being kicked out to bash and constantly being puzzling over weird outputs being echoed by the Scala REPL. So the echoed output's unreadable. Control-C kills everything. So if you have a runaway code, you want to interrupt it. Either you wait to infinity for the code to finish because you know because it's Turing complete, so you don't even know it's ever going to finish, or you kill it and lose all your work. Neither of which are good solutions. You can't sub-process out with borking JLine. I didn't demonstrate this, but you could take my word for it. And there are a bunch of other problems that need to be fixed. So one interesting thing about this is that none of these problems are really problems with Ammonite-Ops. They're mostly REPL problems. In fact, they're all REPL problems. So what if we wrote our own REPL? So writing REPL turns out to actually not be that difficult. And like, people have written like simply Scala.com. You can go and try Scala online. You have learned try Scala.com. Writing a REPL is much easier than writing any of these websites. You don't need to futz with HTML and web servers. You just have the compiler and feed code into it. So Ammonite-REPL is an attempt to do that. So as a goal, you should not need to quit your Scala REPL. You should not need to quit it to open Vim. You should not need to quit it because you need to update your dependencies. You should not need to quit it because you borked the REPL because you did something weird. How often do you restart your bash REPL because you screw up bash? The answer is not very often. So why should you need to do this to your Scala REPL? So Ammonite-Ops is standalone, has both standalone and distributions you can add to any existing SBT project to make your SBT like test console use the Ammonite-REPL. And we can try it. So let's just curl it right here. So that's going to take a while. So I'm just going to use one I downloaded earlier, which is in my home folder. So it takes a moment to load, and here we have our Ammonite-REPL. And you can see the first few compiles are slow because the Scala compiler is very slow, and the Ammonite-REPL does not fix that. But immediately you can see that, well, the Ammonite-REPL pretty prints thing is much nicer than the Scala REPL does. And to show that out even further, if I do something like this, which is purely just to make a whole bunch of a big data structure to show on screen, you can see the Ammonite-REPL actually puts in effort to make the thing nice for you to look at. So this is not going to be surprising for anyone who's ever used, for example, IPython-REPL, which does something similar. So in Python, if I say x for x in range 0 to 10, it does it like that. If I do 0 to 100, it spaces out nicely, like a reasonable person would, not like the Scala REPL does. So for example, I could do list the current working directory and stat all the files. You get reasonable output. If it's too long, it gets wrapped. If I do a full stat which has even more data, all of it basically gets wrapped, and I can show the full thing because it got truncated. There's a bunch of nice features that Ammonite-REPL provides that the default Scala REPL doesn't. So you have good pre-printing, you have nice syntax highlighting. So for example, I don't know if you noticed, I don't know if I actually showed it, but if I list like current working directory / target / I don't know what you get in target, let's target streams. You see that the code you're entering has syntax highlighting, and that's actually very reasonable. There's no reason why your code should be black and white. When you're working in IntelliJ, your code is not black and white, so why should it be black and white when we're working in the command line? It's control-C interruptible. So for example, if I list.recurse root, and I want to print it all, question is, if in a normal Scala REPL, I'd be waiting here trying to guess how many files I have in my file system to decide whether or not it's worth losing the work I already put into that session. Whereas the Ammonite-REPL, you just kill it, just like you would in Python or Bash. You get some neat tricks, like you can live load modules from Maven Central. So let's say I want to try out Scala Z. Decide I'm really into this monadic higher order type level programming thingy. So I look at Scala Z. Here's a website. The GitHub is apparently the best tutorial I could find on Scala, how to use Scala Z. I load .iv Scala Z, and let's just move this here so I don't need to keep flipping back and forth. And I can immediately start using Scala Z in the REPL. So it's that. I do this strange incantation that does funny things with options, and it seems to do the right thing, which is great. And it's not limited to things like Scala Z. For example, let's say I want to try out finagle. Well, finagle is not part of my class path, because why should the REPL have finagle have a web server as part of its class path? But I could, for example, I could just load finagle. And then, in my case, it's cached, so it's a bit faster. If you guys try it, it'll take some while to actually download the jars and cache it in your IV folder. And now I can immediately start doing things. So I can do that. Let's make myself a service in the REPL. So the Ammonite-REPL also has nice multi-line editing, which is kind of neat. So I can, for example, say, I can edit this to say print line, hello, I am a rec. And let's say I want to interpolate this properly. And you can see like even the interpolation is colored correctly. Finish this off, kill it, not kill it, and then complete it. Now I have a server. Paste these in. And now I can immediately start going to localhost 8080 and see my finagle code in action. So that's kind of cute. And this is not something that you'd be able to do in normal Scala REPL, because you spend so much time going back and forth between your build the SBT and your SBT console and your Scala REPL that you'll just forget what the hell you are doing. Whereas in Ammonite-REPL, you pull down the code with one command, you immediately start importing and can use the code right away, including pretty big snippets, because multi-line editing makes it feasible to go back and fix things up. Okay, so the Ammonite-REPL provides a bunch of nice things. And it's basically a strictly better Scala REPL. It is possible there are cases where it's worse. If it is, tell me and I'll fix it. But it's not that hard to be better than what's already there. So kind of like JavaScript, kind of like Scala.js, you don't need to be perfect, you just need to be less worse. And I think this is definitely a case where it is already less worse than what's already out there. It's usable in any SBT project too. So if you add this command to your build SBT file, you can just type test console, SBT test console, and your normal SBT console will become an Ammonite-REPL. And it's usable standalone. So I already showed you, you can download the executable from my GitHub and just run it immediately. So this then begs the question, can you use Ammonite-Ops plus Ammonite-REPL as default shell? So let's try it. So over here I have this project called wood.js. That's actually not mine. It's some other person on GitHub who put it up for a different Scala Days talk. So let's go up. So here's my workspace. You can see I was playing Pokemon recently. I can go into wood.js, see what I have. I don't actually know what all these changes are, so let's git diff. Okay, so let's say I want to make a change. Let's first try running it. So I'm going to open up SBT, because the first thing you do in a project, well, the first reasonable thing you do in a project that you're not familiar with is you see if it actually works at all without any of your changes. So I'm spinning up SBT console. SBT is being slow as always, but here it is. And I can say server/run. So wood.js is an implementation of the Wood collaborative text editing algorithm. So now if I go localhost 9999, I can basically edit text here, and it should come up to the other side by default. But it isn't, because I screwed up. So let's kill that, and let's clean up some of the... Come on, get out, get out. Okay, I'm just going to kill this guy. And let's try that again. So spin up the REPL. The problem is cd up/wood.js. So the problem is my git status was dirty. So I'm just going to like git reset hard head. And then let's try that again. Let's just do server run this time, since I don't feel like typing it again in the console. So It's spinning up, SBT. Come on, SBT, you can do it. So this is it. While it's spinning, let's just talk a bit about what this is. So this is an implementation that has a web server and 2 web and browser clients implemented in Scala.js. What happened here? Okay, clearly this. So let me fix this. I'm going to check out this, git clean XCF, Ammonite, SBT, server, run. So let's see if I can get that working. So what it is it lets you have collaborative text editing in the browser that's implemented using this boot algorithm, which is nothing new. It's well known, published a few years ago. And what's interesting is that it's the same algorithm implemented in both Scala.js as well as Scala JVM, so the code is shared. So this was done as a proof of concept for Scala.js. It's clearly not production ready, but it should, if SBT does my bidding, it should give me a chance to show off how this works, how the Ammonite-REPL will work with Scala.js. Not with Scala.js, with a real Scala project, which in this case includes Scala.js. So let's try this again. Attempt number 3, please work. Okay, here we are, finally worked. I guess I finally cleaned out all the bad state I had. So so now we know this works. I can kill it. You see, interrupting the program doesn't kick me out of Scala REPL. My git status seems to be clean. Let's try making some change to its program. So let's try changing the place where the socket, the port at which it connects to. So I happen to know that the server, I think it's server source main Scala, the main.scala file has important information. So let's go to 8888 here. Let's see if we can find it. Here it is. Let's change it to 9999. Okay, and I also need to change the resources. Let's list this. The resources WebSocket.js file. So where's my 8888? 9999. And then let's say SBT run. Well, that's not right. So SBT server run. So again, this will take a few seconds. So let's wait for it to compile. Hopefully someday the Scala compiler will get faster. For now, we can just twiddle our thumbs as an alternative. Address already in use. Oh, because my earlier server was still running. So let's change this from. Let's change this to like 9988 or something. Let's try that again. Please connect. I swear I didn't have anything looking at listening to port 9988 earlier. Yes?
So when you have to kill a program, have you gotten that working in Ammonite?
What do you mean killing a program?
I noticed that when you need to kill a program, you'll drop out of Ammonite sometimes to kill
Sure.
the process.
So I'll get in that in a second. Okay, so now we have it working. So I'm not trying to bluff you guys. To answer that question, the reason I had to kill Ammonite to drop out just now is because I had a weird checkout of it that had bad code. So after I cleaned up and went to an earlier revision that actually worked, it's fine. So in this case, once I'm back to the normal version of Ammonite, killing a program works great. So for example, I want to do while true print line. Oh no, it's runaway code. Oh no, kill it. Get on with your life. So this works. And as you can see, making changes and stuff works too. You can basically do anything you could do with Bash using Ammonite. So for example, I could open up a Python REPL and start printing stuff. Because why not? I could SSH like my web server. Let's see if this actually works. You could do some things here, whatever you want to do with your normal like SSH work, and then you get out back here, and you can keep going. So that's pretty neat, and I think that kind of answers the question in that even though Scala REPL is not a plausible system shell, with some tweaks, it kind of is, maybe. So this is clearly not something that millions of people are using, but it's something that I think is plausible, and I've used it for hours at a time without getting angry at it. So, and that's much longer than you can survive it using the normal Scala REPL or even using a Python REPL. You'll get angry within about 2 minutes. So you can do real work in the Ammonite-REPL without getting out of the shell. So as another example, you can open like your home /ammonite/predef.scala file and make changes to this. For example, let's say I don't want the last path segment to be my prompt. I want all of the path segments. So I'm just going to say to string. And in this case, because I'm reloading config, I actually do need to reload Ammonite. That's actually not different from bash. And now I have the full path segments. And you could easily put like your bash prompt. You could put like your git branch. You can put your current timestamp, whatever. You can change the color. So I could say like colors. I think it's colors. How do I do this? Colors.prompt equals console.red. I'm just going to do prompt. I'm just going to set it back to the default for now, just because it's really long. And in general, the whole thing is configurable, just like a bash shell would be. You can like tweak with it inside the shell, and only rarely do you need to come out. So this is still a work in progress. We are still missing things like autocomplete. So even though we autocomplete properties and names in scope, like I already showed you here, we don't autocomplete important things like file system paths, which are actually very common in bash. Like maybe 99% of your data structures are file system paths. So they deserve special handling. And there are other things which could benefit from autocomplete as well. It would be nice to fetch Scala doc and show in the terminal. I mean, IntelliJ fetches a Scala doc. I mean, my crappy Python REPL here, if I import OS, I can ask for help on things, and it gives me documentation. So why shouldn't the Scala REPL do this? The Python people have had it for years. And it is very useful. And like Windows support currently is mostly blocked on terminal weirdness. So the file system operations already work. So if you want to use this in existing like application or library, you can do so. But the Ammonite-REPL as a REPL, the colors are all ANSI Unix colors, which are different from the Windows colors. And I don't have Windows, and I don't have the drive to go and fix it. But hopefully someone can help pick that up. So what did we do? So we basically have two libraries. One is, I basically wrote two libraries. One is Ammonite-Ops, which is a really nice file system library. So I'm using it in a bunch of projects. I'm even being paid for one of those projects, which is great. And the other one is Ammonite-REPL, which is a really nice drop-in Scala REPL, which is also great. And together, you have something that could conceivably be your home at the command line. So not definitely, it's not the next big thing yet, but it could be, has a chance, whereas the default Python or Scala REPLs don't have a chance. We re-implemented much of Bash's functionality in Scala. So now I can do things like, I can do ls.rec. I want to see, let's say I want to filter out only files. I want to group by extension. I want to map values. So it's very easy to do things like that, where, let's show it just so we see the whole thing. It's very easy to do things like that, where you can ad hoc run queries on your file system, which in fact are probably too complex for you to come up with to run on bash without looking for Stack Overflow. Like, who in this room would be able to do this without looking at Stack Overflow in bash? 3 people. So that's the goal of, that's kind of the goal of Ammonite-REPL. It gives you a way to do these things. And that's actually, it's not even not difficult. It's obvious. You list the things, filter out the things that you want, group, map, done. So that's what we've done. We've twisted Scala syntax into a weird bash-like form. I know not everyone's going to be a fan of this kind of weird piping or this kind of weird exclamation mark. And maybe it doesn't have any place in a real enterprise-grade software project. But neither does bash, I would argue, because if this is sketchy, then what is bash? So if we accept the premise that having some kind of conciseness is valuable, then this is the logical conclusion that we should make the things that you'd use concise, and they kind of behave like pipes anyway, so just make them look like pipes. And we've re-implemented the whole Scala REPL to make it work. So this is easier than it sounds, but still was a bunch of work. I think it's maybe like 3,000 lines right now for the whole thing, which is OK. So why did we do it? Why couldn't we fix bash, fix Python, or fix java.io or java.nio? And I would argue that the reason we can't do these other alternatives is actually pretty fundamental. So if you look at the space of possible system APIs, you always have this trade-off between danger on one side, verbosity on the other side. And in both cases, you probably have asymptotes. So no matter how verbose you get it, you're not going to lose all the danger. And similarly, no matter how dangerous you're willing to go, you're still going to need to type something to get the computer to do what you want. So there are asymptotes here. It doesn't go to 0 on either end, both vertical and horizontal. Bash, I would argue, is very near what I call the cliffs of insanity. This is a point where you can subtract characters and the danger shoots up like tremendously, and bash is definitely in that case. You miss quotes around some variable interpolation and suddenly expands into multiple things, and you've suddenly deleted your whole database fleet. Java, on the other hand, falls on the other side, where it's so verbose that it's not even doing anything anymore. You're not actually gaining anything from the verbosity. You're just wasting your time. And like Java NIO, I would argue like maybe it's better. Probably is better because it's newer and has more built-in functionality. Python, I would argue, is not actually any more dangerous than Java at doing these things. So part of the reason is that Java, in the planes of diminished returns, is so verbose that it's not actually gaining anything from verbosity. But another reason is that both of Python and Java basically treat paths as strings. You get a path, you don't know what it is. You could have random like ups inside. It may be absolute, may not be absolute. You don't know. You may or may not have to call canonicalize or normalize to get to a path that you actually want. And when you're working in bash, so many of your paths, so many of your data types are paths that when you're all strings, Java's type safety doesn't really get you anything. So where does Ammonite fall on this continuum? So I would argue that Ammonite doesn't fall on this continuum at all. And that's because there are ways to make your code less dangerous while at the same time being less verbose, or being much less dangerous for equal verbosity, or being much less verbose for the same amount of danger. And most of you will be familiar with these ways. Like, it's not magic. There are better ways of doing things for some subsets of the things that you do. Like functional programming, many people argue that using map and filter rather than having while loops and for loops. Sure, it's slower, makes more class files, but it is more concise while at the same time being easier to reason about and harder to get wrong, and therefore less dangerous. Similarly, inferred types give you a large amount of the safety benefits of having a typed language without the verbosity, because you just don't write the types. The compiler figures it out. So this actually lets you push the whole curve. And I would say Ammonite falls somewhere here. Less than twice as verbose as bash. Bash is somewhere here, Ammonite's here. While still being more safe to use and less dangerous than any of the existing alternatives. So one cute demonstration is that I have my current working directory. The current working directory is absolute path. I can have relative paths. I can combine relative paths with other relative paths. So res10/res10, longer relative path. I can combine absolute path with a relative path. I cannot combine an absolute path and an absolute path, or a relative path with a relative path. Sorry, or a relative path with an absolute path. And why would you ever want to? Like, what meaning does combining users twice give you? It actually doesn't give you anything. And with Ammonite, it gives you this degree of safety that you don't have in Bash, Python, Java IO, Java NIO, or any other file system API I've seen. So there are problems with using Scala as your shell. So JVM is slow to boot when you have a bunch of class files. I know the hello world is maybe 40 milliseconds. Once you're loading Scala compiler, Scala library, Scala reflect, and a bunch of other things, it usually takes several seconds to boot. And this includes all the class loading that's going on. And the first compile is slow. So it's easy to demonstrate this. I go back to Bash. I open up Ammonite. 1, 2, 3, spins up. First compile. 1, 2, 3, 4, and then it works. And of course, after that, it gets faster. But even at its peak, if I'm doing this over and over, there's still a 0.2 to 0.3 second lag, which is noticeable, especially when Python literally takes 40 milliseconds to spin up, and doing work is more or less instant. So that's a pain. Python are fast, Scala is slow. The Ammonite-REPL is kind of fat as an executable. So the jar itself is 30 megabytes, no JVM. Plus JVM, it's going to be more than 100. And that's fat for something that doesn't actually need so much functionality. So there is hope, because the one benefit of being in a large ecosystem is that other people can do work for you, and I don't even need to pay them. So like Java 9 modules would help cut down the size of a JVM to make bundling smaller, which would be great. And like the Java 9 people have been talking about closed world optimization for their modules. Like the Dotty people have been talking about closed world optimization for the modules, which would possibly make the modules that we load as part of the initial Ammonite start smaller and thus faster to class load. Because it doesn't matter how fast a JIT makes it, because the first time, you always have to load all this trash. And hopefully Dotty will make things faster. If it makes things slower, no one's going to use it. So there's only one way it can go. So looking at our original application architecture, it looks something like this. Danger, a small island of safety where you can revel in your type-safe monads, but everything else is basically crazy. With Scala.js, we fixed a bunch of things, but there's still this huge spiky underbelly, which is possibly problematic. The goal of Ammonite is to try and solidify that stuff. And it's not meant to be type-safe, monadic, reactive, enterprise-worthy, but it is meant to be something that you can reasonably rely on, and at least you know to at least parse the way you expect it, never mind run. And in our case, we even have type checking. So Ammonite-Ops could partially satisfy the use of Bash and Python as a file system manipulation library, while Ammonite-REPL could substitute use of Bash as a shell for you to live in, to do all your work in, to open up SBT, to commit stuff to Git, to push things, and all those other nice things. So, and that's how I think it's possible for us to finally move beyond Bash. So here's the docs. Here's snippet if you want to use it as a library or use a standard executable for the REPL, and I'll take questions. So the question is, when I'm typing commands, sometimes I'm using strings, and sometimes I'm using symbols. And the answer is they are exactly the same. So if you can use a symbol, just use it and save one character. And in this case, the assumption is characters are important for live usage. So that's why I do this. Any other questions?
Why do you sometimes present, like in the Git example, and sometimes bang?
OK, so let me reset my prompt first, actually. So prompt, because it's really long and hard to use. So let's set that. So the difference is that the things that you bang are functions that live in Scala land. So basically, I have my own implementation of list, mkdir, and whatnot. And in general, these are aimed to behave better, for some degree of better. So for example, RM works in everything rather than just being the bash RM. But there's always a long tail of things which have not been wrapped. Like you could wrap them, but there's always going to be a lot of things. So Git, SBT. I should not have used SBT. It's really slow. like arc for if we use fabricate at work, and tail, that sort of thing. So percent is basically a convenient to use shell out, while the bangs are built-ins that are presumably useful. And percentage, so you won't get any code completion on the percentages, not any useful code completion anyway, because it uses dynamic. Questions?
So this is great as a replacement for Bash is sort of an interactive shell. But the other thing that we use Bash for all the time in our house, you mentioned, is Bash scripts.
Yep.
Fire off. So does Ammonite have a thing where you can load the code and fire off Ammonite scripts?
Yeah, it does. So let me show you. What do they call it? I called it REPL. You can see without having syntax highlighting, it's kind of pain. Source, test, resources. Does that work? Source, test, resource, standalone, hello.scala. So this is a thing. So let's just cat this to take a look. So this is a script that should, in theory, print out hello world. And I should be able to, this is not Ivy, it should be load.module. And then it prints it out. So there are a bunch of limitations that will eventually be solved. Like for now, a script cannot load other scripts purely as an implementation problem that we did it wrong and we'll need to fix it. And you can see that the REPL, the command line is still slightly buggy. But yeah, you can load scripts, you can define scripts and load them, and it works. Questions?
So does your file system like rm, error, and ls call back to the batch underlying, or to the wrapper over the JDK library?
Those are all wrappers over JDK.
Okay.
So either IO or NIO. In theory, yes, if you're willing to put in a bunch of work, but it's not currently decoupled. In theory, anything can be decoupled.
Does it recognize environment variables?
It recognizes environment variables. It does not currently give you a nice syntax to set environment variables for your subprocess calls. So that's a limitation that will need to be fixed to make it usable.
What about permissions? Can you sudo?
I don't think I've exposed sudo yet. In theory, so I guess the worst come to worst, you shell out to bash and sudo things in here. You can't do that. Yeah, so you can sudo by shelling out, I suppose. Not quite as satisfying as sudoing and being able to do like commands like that, for example. But if you need to, you can. Other questions? One back there. Is that a question? That's not a question. Okay, go for it. That's actually perfectly reasonable in many setups. But this is meant to work in existing setups, not the ideal mono, like single process OS. Any other questions? Okay, going once, going twice, going 3 times, gone. Okay, thanks.